And today we are going to be doing another geometry proof. Today we are going to be proving that the inner angles of a triangle always add to 180 degrees. So if we were to have a triangle like this one, we're going to prove that these three angles add up to 180 degrees. So, first off, a review from our last video. We proved that vertical angles are equal. So if we have two angles like this, if these two are vertical, if angle 1 and angle 2 are vertical, then angle 1 is equal to angle 2. Alright. Now, before we do our main proof, let's do a shorter proof that we'll need to do our other proof. So what we're going to be proving here is that the alternate interior angles of a transversal are equal. So I'm going to use a ruler for this because it's pretty important that we get this straight. We have something like this. Lines 1, lines 2, and line 3. In this case, we have I'll do three angles here. Angles 1, 2, and 3. What we're going to be proving is that angle 1 and angle 3 are equal. So, in this case, we're proving that 1 and 3 are equal in the case that line 1 is parallel to line 2. So we're going to make a 3-column proof, or 2-column proof. Why did I say 3? Statement and reasoning. So, first, we know that line 1 is parallel to line 2. That's given. Line 3, this one right here, is a transversal to these two lines. We know that by just inspecting the image. Now, angle 1 and angle 2 are equal by something known as the corresponding angles postulate. Whereas if these two lines are parallel and cut by a transversal, these two angles are always equal. So this is by postulate. Now, by what we just showed above, angle 2 and angle 3 are equal by vertical angles theorem. If you don't know what that proof is, I'm talking to you, future me. Go to Geometry Proof 1, where we prove this. Vertical angles theorem. So lastly, we know that angle 1 is equal to angle 3 by substituting the 2 for 3. Substitution. Alright. Now that we've done this, we can prove the triangle. So, final topic, topic 3. If we have a triangle, and I'm going to use a ruler for this, and I drew that too steep. Let me try that again. I'm going to draw this pretty big. Like so. If we have a given triangle like this, with angles 1, 2, 3 at points A, B, and C, given this triangle, ABC, we are going to prove that angle 1 plus angle 2 plus angle 3 all add up to 180 degrees. So we're going to make another 2-column proof. Statement of reasoning. Okay, so our first 3 statements are going to be pretty much the same thing. We're going to be extending these lines. So there's a postulate that states that in any line segment, we can extend that line segment. Like forever. So we're going to extend AB, extend AC, and extend BC. And what that's going to look like is once we extend all of these, like so, like that. You don't need to extend them too far, just a little bit of work. Like that, and then this bottom one. There we go, that's enough. Okay. Now, here for our next statement. This is known as the fifth postulate. Actually, let me write these in real quick. Alright. So what we're going to do is we can construct a line through C and some point D that is parallel to line AB. So something like this, and say point D was here. Like so. This is known as the fifth postulate. Next, we're pointing out that AC is a transversal to lines CD and AB by inspection. So that means we know that if these two, due to the theorem we just did, we can name these angles 4 and 5. Knowing this, angle 1 is equal to angle 4 by our theorem in topic 2. So I'm just going to write topic 2. Same with angle 2 and angle 5. If we point out that BC is a transversal by inspection, we can show that angles 2 and angle 5 are equal by topic 2. So now, what this shows is that basically, since these are all on the same line right here, all three of these have to add up to 180. So that shows that angle 4, angle 5, and angle 3 are all equal to 180 because inspection of a line. So lastly, we can substitute 1 for 4 and 2 for 5. And that proves that angle 1 plus angle 2 plus angle 3 is 180 degrees by substitution. Like so. Bye.